still got my coffee, baby. Woohoo! I'm kind of tired of it. Anyway, we're going to work on 7.5 notes, trigonometric identities, and let me just tell you something that you really want to hear. The word proofs. Sort of. These aren't bad. They're a little weird. They require some memorization from you. My name is Mr. Krause. You can call me Mr. Key. Last time I tried to show you the old website, kind of screwed up there a little bit. MrKrauseMath.com. All of this stuff can be found here. Just go to Algebra 2. We're in Unit 7. I don't have all the videos up. They'll be up by the end of the day. There they are, the entire units right there. You click on that sucker. All 75 pages of this unit are available to you for download. I don't know how many pages it is, whatever. Anyway, there it is. Let's get going. So let's talk about side ratios. Well, before I talk about those side ratios, let me get down on here something that we need to talk about. Not really. Some old horse caught another horse taking oats away. Pick one you like and stick with it. Now remember, this one goes with cosecant. It is the reciprocal of cosecant. So cosecant would be H over O. Since this goes with cosine, and we know cosine is adjacent over hypotenuse, this is hypotenuse over adjacent. And this one goes with tangent, and tangent is opposite over adjacent, so cotangent is adjacent over opposite. Now sometimes, remember they're called reverse or reciprocal identities. That's because cosecant is really 1 over sine. And I guess we're using x, we'll use x. Secant is really 1 over cosine of x. And cotangent is really 1 over tangent of x. Now we'll generally not use this one. And that's because we talked about the other day these two things right here. We proved the one the other day. I think it was yesterday. That tangent is really sine of x over cosine of x. Well, if this is the reciprocal function, then cotangent of x is really cosine of x over sine of x. Now, you need to have these ones committed to memory as well as these two. This one right here doesn't really come up into play, but the other two do, and you really have to have a good handle on those. All right? So get a good handle on this. So here's what we're going to do. We're going to use the reciprocal and quotient identities to simplify these, to simplify this expression. Okay. Now here's generally what you want to do. You really generally want to take whatever you have and turn it into sines and cosines. If you can figure out a way to turn it into sines and cosines, you're in pretty good shape. So we know that cosecant is 1 over sine of x. They are reciprocal functions. We know that tangent is equal to 1 over cotangent, but that's freaking useless, right? We don't need that. What we need to know or remember is that tangent is equal to sine of x over cosine of x. And finally, this is cosine of x, but we're going to leave it as cosine of x over 1. Now, did you notice how I turned them all into fractions? Even this cosine of x I turned into a fraction. That way they're all fractions. And since they're being multiplied, everything's being multiplied, I can just cancel things. So this sine x cancels with this sine x, this cosine x cancels with this cosine x, and I'm just left with 1. This whole thing is 1. So no matter what angle you put in here, you're going to get 1. Now you want to prove that? Watch this. Let me go over to your calculator, which I don't. There it is. I have the calculator available. Let me go to the calculator. And you know what I'm going to pick? I'm going to take 51.875, and I'm going to store that into x. And I'm going to press enter. Now I'm going to do, don't remember what it was, cosecant of x times tangent of x times cosine of x. And it'll be 1, no matter what. no matter how I put it in there. It simplifies simply to 1. All right, so remember we talked about this yesterday as well. We got to be really careful with what this means. So I'm still going to write this as a fraction, but I'm going to write it as cosine of x squared over 1 times 1 over cosine of x times 1 over sine of x. Now, this cosine of x cancels with one of these. Now, if you don't like that or that confuses you, you could write cosine of x squared as cosine of x times cosine of x and say, okay, now I'm just going to get rid of one of them. So remember, we're going to multiply across the top. So what I have left over on the top is cosine of x. And what I have left over on the bottom is sine of x. Well, you still have to simplify the expression. Cosine x over sine x, if you remember correctly, is cotangent x. So you can't leave this as your final answer. It's not simplified. This is really cotangent x. And again, I could practice. I could check that on that, but I'm not going to. So here's how we're going to do this one. We're going to do sine of x over 1 times 1 over cosine of x all over sine of x over cosine of x. Now I don't need to do this. There is a different way to do this problem. There's almost always a different way to do these problems. But I want to show you something. If you divide by a fraction, notice how in the denominator we're dividing by a fraction, correct? So we are dividing by that fraction. Dividing by a fraction is the same as multiplying by the reciprocal. Okay, now that I've done that, this cosine x cancels. This cosine x, this sine x cancels. This sine x, and I'm left with 1. Now, why did I say I didn't have to do that? Because I could have left this as tangent of x. Now, why would I have done that? Well, in the numerator, if I multiply these across, I get sine x over cosine x. Well, sine x over cosine x is tangent x. So in the numerator, I get tangent x over tangent x, which equals 1. I want you to really remember that dividing by a fraction is the same as multiplying by the reciprocal. All right. So these are you tries, so you should probably pause this, try 3 of these, and come back. I'm going to walk through them anyway, but pause and try them. You should pause. All right, you're back. Okay, good. You should have done this. 1 over sine x times 1 over cosine x times cosine x over sine x. Well, cosine x cancels. So I'm left with 1 over sine, and you got to write this correctly, sine squared x. Because that's what sine x times sine x is. It's sine squared x. So some of you didn't like the way I did that before. I know you didn't. So I'm going to write this as sine x times sine x, because that's what the squared means, over 1 times 1 over cosine x times 1 over sine x. All right. One of these sine x's cancels. So if I look across the top, I'm left with sine x. In the denominator, I'm left with just cosine x. So that is equal to tangent of x. And finally, here we got one that says tan x is sine x over cosine x times 1 over cosine x times cosine x over 1. Well, that's really dumb because those cancel, and I'm left with this, but that's really just tangent of x. By the way, these problems are virtually impossible if you don't memorize this stuff up here. It has to be memorized, okay? Get it down. All right, I'm going to take a little pause. I'll be right back. All right, here we go. We're going to turn them all into sines and cosines. So the numerator becomes sine x over cosine x. Now, see how this one's a longer fraction line? right? And then I do a little fraction. And then secant is 1 over cosine x. Now again, dividing by a fraction is the same as multiplying by the reciprocal. Cosine x's cancel, and I'm left with sine x. All right, what do we got here? We got a minus. Ooh, you got to be careful. We got to separate these two things. We got to keep them separate. So this is 2 over 1 times cosine x over 1 times 1 over cosine x times sine x over cosine x times cosine x over sine x. Now we got to be careful. These cosine x's cancel, so this leaves me 2 minus sines cancel, cosines cancel, 1. So this answer is 1. That whole thing turned out to be a big old 1. All right, this one's going to be pretty simple. 1 over sine x divided by cosine x over sine x. But dividing by a fraction is the same as multiplying by the reciprocal, sine x over cosine x. So the sine x's cancel. So what I'm left with in the numerator is 1. And in the denominator, I'm left with cosine x. Now, you can't leave it like that. You have to remember that that's really secant of x. All right, get those down. All right, it's really important you get those down. Now we're going to do a little bit of cray-cray stuff. So let's go back to the unit circle. Let me show you something that you may not. I'm going to teach you your first huge, and I mean huge, bigger than that guy on that commercial, identity. Okay? Now, remember when I said, let's go back and create a right triangle. Remember when I said that we had this as A and B, and I said, okay, this distance is A. Remember, this is a unit circle, so this is 1, and this is B, right? Well, and then we said, okay, this is really cosine of theta, and this is really sine of theta. Well, what's the most famous thing that I can do in a right triangle? If you said nothing, I feel accomplished as your teacher. If you said the Pythagorean theorem, otherwise known as the Pythagorean theorem, then you said like, oh, okay. Now the Pythagorean theorem says if I do sine squared theta plus cosine squared theta. In other words, a squared plus b squared equals c squared. And 1 squared is 1. Oh, that means if I take cosine squared, if I take sine squared and I add cosine squared, no matter what, I get 1. Is that true? That doesn't make any sense. Let me check it on the calculator. So, now remember, when we put cosine squareds in, we got to do a little funky. Oh, well, it doesn't matter. X. And we'll do a squared. Plus sine. Doesn't matter which order I go in. X squared. No matter what, I get 1. Now, I can pick any value I want. What if I wanted negative? What if I wanted negative 151.875? Let's see what cosine squared plus sine squared equals. No matter what, it's always 1. This is an identity. In other words, it is always true. It is a fundamental always truism. That's not even English. Star this, huge, huge. Now from this, we're going to get a couple of crazy ones. All right. So from this is what mathematicians do, by the way. They're like, you know what? That's not confusing enough. I want to create a couple more identities. So we're going to create identity number 2. And we're going to start with the idea of sine squared x plus cosine squared x equals 1. Theta, x, it doesn't matter. And here's what we're going to do. We're going to divide this whole left side by cosine x. Excuse me, cosine squared x. Now, why did we do that? I don't know. We're mathematicians. We like to mess with stuff. But we did it because if I divide the left side by cosine over cosine squared and I divide the right side by cosine squared, that's legal. I'm allowed to do that as long as I do it to both sides. Well, what is sine squared over cosine squared? Isn't that just tangent squared of x plus, and cosine squared over cosine squared, that's just 1, is equal to, now 1 over cosine is secant, so this must be secant squared of x. And there is another truism. There is another one you get to commit to memory. It will be on a quiz. We're not done. The good news is, if you start with this, you can always get these, because this one gives us this. Now, let's do it again. We're going to start with the one we know. The one we know is sine squared x plus cosine squared x equals 1. But this time, you guessed it, we're going to divide by sine squared x. So we're dividing both sides by sine squared x. Why? Because we want to. We're math people and we like to mess with stuff. So we're going to create a new identity. Sine squared over sine squared is 1 plus cosine squared over sine squared is cotangent squared x equals 1 over sine. 1 over sine is cosecant, so this is cosecant squared x. And there is another identity. Now, how do I remember these? First of all, the c's go together. On this one on the right, the c's go together. On the one on the left, the tangent and s, they're kind of close to each other alphabetically. All right, let's go simplify each expression. So what are we going to replace cotangent squared with? Wait, cotangent squared x plus 1. Isn't that just, that's an identity. That's cosecant squared. Oh, so that's just cosecant squared x. Well, that was pretty easy. 1 minus secant squared. Wait a second. 1 minus secant squared. Well, what can I replace secant squared with? I know, let me get rid of this yellow. I know that secant squared is really tangent squared plus 1. So I'm going to replace that. 1 minus, when you replace, use parentheses, tangent squared x plus 1. Okay, so what do I really have? I really have 1 minus tangent squared x minus 1. The minus 1 and the plus 1 cancel, so I'm left with negative tangent squared x. Now, all of this stuff is you just getting comfortable with weird stuff. That's what all of this stuff's about. Can you get comfortable memorizing a few things and then algebraically manipulate some weird stuff? All right. So here, let me ask you this question. What is 2/5 plus 1/5? Would you agree that's 3/5? Or could you also agree that that's 2 plus 1/5? So if I had, let's say I had x over 5 plus y over 5. Since the denominator is the same, can't I keep the denominator 5 and just add the numerators x plus y? Well, the reason I ask you that is because what I want to do is start here, and I want to split up and break up the fractions. And that's what we're going to do here. That's a property of fractions I'm allowed to do, and hopefully you learn that at some point in your life. So what I want to do is I want to create this as one fraction and this as another fraction. So I've got cotangent squared x over cosine squared x minus cosine squared x over cosine squared x. Now, I'm not saying this is the best way to do this. As a matter of fact, I'm probably going to erase this and do it a different way. I don't know. Maybe I will. Maybe I won't. Let's see. So this part's easy. It's just 1. But this part's a little bit tricky. It's a wee bit tricky. So what we're going to do is we're going to turn cotangent x into cosine squared x over sine squared x divided by cosine squared x over 1. Now, why did I turn that into a fraction? Well, didn't I just say a few minutes ago that dividing by a fraction is the same as multiplying by the reciprocal? So this is really the same as multiplying by 1 over cosine squared x. Okay, well, how does that help? Well, these cosine squareds cancel. I'm left with 1 over sine squared. 1 over sine squared is cosecant. What the heck just happened? 1 over sine squared is cosecant squared x minus 1. But what is cosecant squared x really equal to? Isn't it really equal to 1 plus cotangent squared? So this is really 1 plus cotangent squared x minus 1. The 1's cancel, and I'm left with cotangent squared x. Hopefully that's not behind my head. So, was that the best way to do that problem? I don't know. Let's see if we get come up with a different way to do this. What is cotangent squared x really equal to? Why can I not? Let's see if there's a different way to do this problem, because sometimes there's a different way. So, yeah. Nah, would have made it. That's probably the best way to do it. That was a tough one. That's a tough one. Some of them are a little bit easier, some of them are difficult. Some of them more difficult. All right. Verify the identity. Remember I was foreshadowing proofs? Proof. Hold on. Let me come back. All righty. We're going to be doing some proofs. And the one thing I want you to remember is that you are only allowed to change one side to make it look like the other side. You need to pick the more complicated one. So find the more complicated sign and change it. This is not difficult. This is like proofs on for 4th graders. As long as you have memorized the things, you should be in pretty good shape. So same rules. This is the more complicated side. So we're going to mess with this side. So I'm going to change it. Same as I did before. Sine x over 1 times cosine x over sine x, and I need to prove that that's equal to cosine x. All right, so let's see. These cancel. And what do I have left over here? Cosine x. So what I have is cosine x equals cosine x. Ka-ching! By the way, this last statement always has to be this. It's so obvious, but it's going to be a 2-point question, and some kids aren't going to write this, and you're going to get 1 out of 2 points. Don't do that. All right, this side's the more complicated side. We want to see if we can make that equal to cotangent x. So, okay, no problem. So this is 1 over sine x divided by 1 over cosine x, and we want to show that that's equal to cotangent x. So when I'm done, I better have cotangent x equals cotangent x. All right, so how do we divide by a fraction? We multiply by the reciprocal. So what I have here is cosine x over sine x, but isn't that cotangent x equals cotangent x? Now, the reason these are so easy is because you know what you got to end up with. That's what you got to end up with. Let's do another one. When we're done, it's going to say tan x equals tan x. Let's do it. 1 over cosine x. Why do I keep doing that? times sine x over 1 equals tan x. Well, it's not good enough at this point that says, oh, okay, yeah, duh, that's tangent x. You actually have to write it. Oh, that's tangent x equals tangent x. Now, if you want to include the intermediate step by going, oh, that's really sine x over cosine x equals tangent x. But your last line has to be that one. Don't skip it. Just go, oh, yeah, duh, that's tan x. I'm done. It's not good enough. You got to finish it. You got to finish the proof. All right, cotangent x. Cotangent x is cosine x over sine x. And then this is cosine x over 1. Make everything fractions, kids. Everything fractions. We want to prove that's equal to... Now, some kids are going to go 1 over sine x. But if you do that, you have messed with both sides. You are not allowed to do that. You're not allowed to mess with both sides. So you have to leave it as cosecant x. So multiply by the reciprocal. These cancel. And I'm left with 1 over sine x, but I know that's cosecant x, and therefore it equals cosecant x. Ka-ching! God, these are simple. They do get a little harder. Hope that's it. Okay. All right, here we go. Wait, how many do I got left? Oh, I got 6 left. You probably want to pause this right now and try these on your own. They're really fast. So pause it, come back. Hey, you're back. Okay, so you can either scrub through and see. You know you got them right if at the end you wrote cotangent x equals cotangent x. But you can scrub through and see. This is cosine x over 1 times 1 over sine x. And I want to prove that that's equal to cotangent x. Well, this is cosine over sine. That's cotangent x equals cotangent x. Simple. Ooh, we got us an issue. Well, maybe we do and maybe we don't. So I'm going to do this 2 ways. I'm going to do it the hard way first, and then I'm going to do it the easy way. So let's do it the more difficult way. You can see that. So cotangent x is just cotangent x. Can't mess with that. But I'm going to change this to sine cosine of x squared over sine squared x times sine x over cosine of x. Now, this cosine x cancels with one of these. This sine x cancels with one of these. I'm left with cosine x over sine x, and that's cotangent x equals cotangent x. Now, why was that the hard way? Well, you're about to see. This is that one time when you don't want to turn these things into sines and cosines. So cotangent x is equal to cotangent squared x over 1 times 1 over cotangent x. Because tangent is equal to 1 over cotangent, because they are reciprocal functions. So this cancels with one of these, and I'm done. Cotangent x equals cotangent x. Either way, they were pretty easy. Doesn't really matter. I think turning things into sines and cosines is always a good idea. This one should be fast. Sine x over cosine x times cosine x over 1. The cosine x's cancel. And it's not good enough to leave it like this. You need to write sine x equals sine x. It's going to be a 2-point question, and this has got to be your last statement. Crap. All right, so this is going to be sine x over 1 times 1 over sine squared x. I'm not going to write sine x. That's just a waste of time. This is equal to cosecant x. Well, let's see. These sine x's cancel. Wait, 1 sine x cancels. So I'm left with 1 over sine x, and I know that's cosecant x equals cosecant x. 2 left. Now, this one's got a weird symbol. Actually, I don't remember what symbol this is. It's a weird one. Someday you can look it up. But this, well, I don't even know what side's more complicated. I'd say the fraction is more complicated than this side. It really makes no difference. But what we're going to do is we're going to split this up. So we're going to turn this into sine of over cosine of, I don't even know why do we pick this stupid letter? Minus 1 over cosine of, does that equal tangent of, all right, I'm telling you right now, I'm changing these all to thetas on the next one, minus secant of, all right, well, what is sine of stuff over cosine of stuff? Isn't that tangent? I'm just writing theta. Minus 1 over cosine theta. Isn't that just secant of theta? Equals, oh, tangent of theta minus secant of theta. Now, you may have chose to do it a different way. You may have chose to do it this way. You might have said, you know what? I don't mind fractions. I actually embrace fractions. So I'm going to leave that as sine of theta minus 1 over cosine of theta. Cosine of theta. And then we're going to look at this side. Well, this is sine theta over cosine theta minus 1 over cosine theta. Well, don't they have the same denominator, so can't I combine them? So on the left side, I have sine theta minus 1 over cosine theta. But since these have the same denominator, I can put them together, cosine theta, and the numerator is sine theta minus 1. Again, if you don't know that's equal to that, and you don't know that's equal to that, you're not going to be able to do these. If you do it, and you know it, and you've memorized it, it'll be very, very easy for you. Last one. Oh, crap. Let's see what we got here. So the right side is clearly more complicated. So cotangent squared x equals cosecant squared x plus cosecant x minus cosecant x minus 1. Now, many of you realize these were conjugates. You're like, they're conjugates, Krause. You don't have to do these middle terms because they're just going to cancel anyway. That's fine. Good. Glad you saw that. Cotangent squared x equals. Now, what can I replace cosecant squared x? Can't I replace that with 1 plus cotangent squared x? Isn't that one of the ones that I learned on this page? Where is it? Right there. 1 plus cotangent squared is equal to cosecant squared. Got to learn it. Got to have it memorized. All right. Well, wait a second. Then isn't 1... Oh, and then we got minus 1. Well, now the 1's cancel, and I'm left with cotangent squared x equals cotangent squared x. Not bad, huh? All right, it's not bad if you memorize this stuff. I guarantee you some of you aren't, I'm not memorizing. I can't memorize that. And you'll never get it right. So stop doing that and memorize. All right, guys, catch you on the flip side.